Hello, everybody. My name is William Wei. I'm the CTO of Foxconn and MIH Consortium. Today, I want to talk about a software-defined vehicle. We're building an open EV platform, and let me start my slide. So since MIH was announced, in 12 months, the MIH opened up for a partner to join us. And in 12 months, we have reached more than 2,000 global partners, including some large company in tech sector and also some startup company who are really excited to building this open platform together. So I want to start my speech about Mark Anderson 10 years ago, talking about software is eating the world. But 10 years later, 2020, the AI expert from Tesla, they are building some amazing autonomous driving software. And he also say that software is important, but his quote is software 2.0 is eating software 1.0, meaning that the next generation of software is building out of a lot of AI training, building from big data instead of building from a human being algorithm. So this trend continue to lead the innovation. So the power of software start out with before even iPhone, right? Everybody might be remembering that we enjoy our hardware gadget. All the gadgets are like in a form of hardware. You have to carry them around, including the Nokia, the king of the phone. Right? Everybody enjoy and being using Nokia. But 2007, what happened was by the introducing of the iPhone, everything become a software defined. What I mean software defined is you can enjoy all the functionality without carrying this hardware gadget, hardware phone, and more. So you can start taking away all this functionality in your pocket and deliver in a software form that everybody enjoy. So software defined is no longer a myth. Now I want to talk about the open movement. So starting out the closed system building of Nokia, right? Everybody know that Nokia phone is the best phone at that time before Steve Jobs introduced iPhone. But what everybody not noticing is the introduction of SDK, a software development kit, along with iPhone, this piece of a gadget that people bring in their pocket. But what Nokia doesn't have is this rich software development platform, SDK. And later on, Android, after iPhone introduced and then introduced the SDK, Android also follows suit with the SDK in an open source form. And they even go further, open up the hardware platform. So everybody can take this SDK, build a rich software ecosystem, and also they can build their own Android phone. And this really revolutionized the industry. So the power of software defined and the power of openness really is changing the whole industry in different sectors. And in automotive industry, we realize that we want to introduce what we call open EV platform, MIH. What MIH means mobility in harmony. So we start out taking a look at this traditional automobile. Now the first thing what we do is to partition the hardware, what we call skateboard. This skateboard is the traditional OEM call it rolling chassis. Basically, this engine, combustion engine, that taking out, and remaining is just a motor and a battery driving around without any cap top. Cap top is just a design, but this is robust of this skateboard, what we call in MIH is a hardware platform. With this, we can put on top of this hardware platform what we call EVKit, the software stack. And to kind of graphically illustrate, EV skateboard on the bottom. Once we define this abstraction layer as a piece of a skateboard that can be controlled by command, what we call drive-by-wire. On top of it, we can start developing what we call EA architecture and putting on some OSs onto this skateboard. Usually it's RTOS, it's a real-time OS, and it should be a microkernel. It's really a piece of robust OS that on top. Now, the modern software stack usually has, besides OS, usually has this unified runtime, what we call middleware, that open up the whole system software in a form of API. And this rich of API that access all the vehicle system, we call it EVKit. Now, EVKit is open up for all the developer, third-party developer, including car maker, OEM, so they can start defining this skateboard, a different user experience, what we call apps or application, right? So all the application we divide into two domains. One is mission critical domain application, such as autonomous driving, or the robust of functional safety require application. And then you will have a lot of non-mission critical, more of user experience rich of application can sit on top of the EVKit. And all these application, including AutoSAR Classic, mostly mission critical, and ADAS, over-the-air delivery, OTA, and digital key, all this in mission critical domain. And a lot of AutoSAR adapted, what we call open topic, as well as infotainment, such as today you can see Alexa Auto, Android Auto, and Apple CarPlay. All this is in your smart cabin. And these are all non-mission critical application. And all this application can call EVKit API that we provided through the runtime to define the future vehicle behavior. So in fact, a lot of application that coming into this platform, we can see that the first killer app should be autonomous. So autonomous driving by wire is very critical foundation of a mission critical software. We will open up what we call EVKit drive-by-wire framework to this abstraction layer encapsulate a lot of very complex vehicle control algorithm, and then open up kind of in a more high language interface to all the application that try to control the car, which is autonomous driving in different level, level 2, level 3, up to level 5, that when you can really take out the steering wheel or your pedal and brake. So in fact, by pushing autonomous driving layer from the system layer to the application layer, we can enjoy this vibrant, different type of personalized application to control your car. And you can create a marketplace for ADAS, a player to come in to share this a common platform, which is a skateboard that is swappable, right? So it's a skateboard agnostic design. Second is the very beneficial for the industry is the commercial application, such as fleet management or robotaxi. And all this the fleet management robotaxi it's in operational term, it's an API connect to all your fleet vehicle. So today, if you want to build a fleet, you are dealing with this closed architecture of the individual vehicle. Now, EVKit really opened up vehicle architecture and provided different API for access individual vehicle to construct a fleet management sort of platform for the operator. And so is a robotaxi. Last but not the least is the connected vehicle, connected car. Once the car becomes 24/7 connected, you will have a lot of smart mobility API that allow EVKit to open up for everybody to make the application, especially integrating with a smart city. Smart city has a localization issue because each smart city has a local regulation and local rule that are implemented locally. So a global vehicle with API open, they can localize to deploy to different smart city easily. So in a way, we are building up, the industry is building up this EV, what we call the mission critical data center robot. It's not even just a piece of computer. It's a very smart robot with a heavy data generation capability. So we call it a mission critical robot, meaning we have a lot of safety issue that we have to take care. Different from the smartphone industry. How we define a mission critical? We define mission critical to be a real-time requirement and security, cyber security mostly, plus a safety. In the real-time domain, we have to implement the infrastructure that based on the RTOS, the real-time OS, and edge devices, meaning each car is a very thick edge, and by connecting this edge to the cloud, we will make sure that this functional safety requirement to be a lot of deterministic characteristic, including the OS level and also your SoC level. And last but not the least is because the high bandwidth of communication and close to real time 5G, 6G, and also we will bring the content delivery network too close to the edge and to be a real time. On the security end, industry, besides the powerful personal computer and the smartphone, we are coming up with this. This is EV that we put literally 100 of the top high performance computer into the EV. So it's a very, very high computational device and very expensive and safety concern device connect to the internet. So the security, especially cyber security, is very, very important. We take on the philosophy of the new trend of zero trust security from the bottom up. That the edge device need to ensure that there is edge zero trust, edge to cloud zero trust, and provide this end-to-end encryption as well to deliver this vehicle life cycle management, meaning every vehicle when from the born to retire, all this life cycle need to be 24/7 managed, so we can enjoy the future what we call predictive maintenance and also remote diagnostic characteristic. About safety, industry has been very mature about what you can hear a lot of this ISO 26262 and the newer cybersecurity related ISO 21434. This standard need to be observed and need to be followed and need to be certified. The first thing is safety. So we want to make sure that the drive-by-wire and sensor fusion, all these fundamental and infrastructure supporting the future autonomous driving is very safe. To develop, allow the application developer to deliver the best-in-class autonomous of the vehicle. So based on the power of software defined and also the open of way of building up the system, the EV system, there's a couple of key disruption will happen. First is, so the future EV based out of EVKit will be enjoying the digital twin, sort of cloud native, both in development stage to deployment stage, and enjoy the digital twin characteristic of the EV. And the second, it will dramatically reduce the development cycle. So usually you have this very long V shape of the development cycle. It can broken up into more agile development cycle and enjoy the latest CI/CD development methodology. And the most importantly, it will dramatically reduce the entry of the barrier. So all the different domain, especially in the software sector, that we have been enjoying all the innovation from the internet space, from the smartphone, and also a PC computer space. They can all enter the automotive to deliver all their innovation. There's one more thing, last thing that we want to mention, that program, when the famous program, the VC godfather, when he saw Tesla, he was saying like Tesla Model S was like the iPhone for the industry, but he didn't see any Android. There's no analog of Android in this situation. So the goal of MIH is to bring along this open EV platform, we call Android of EV, if you will. Now let's compare the Android ecosystem. You have this open handset alliance that all the third-party either phone maker or the software player application layer, they can come in to deliver the whole Google Pixel Android experience. On the bottom, you can see all the app, the framework, the native library runtime, and you can see from our design point of view, in parallel from the MIH EVKit, we have the similar runtime middleware to open up to all the developer. We're MIH partner now. Today is fastly growing. It's past 2,000. Today is actually 2,300 something. And then on top, we'll have MIH reference design, the final vehicle reference design, together with the rich of application ecosystem to complete the future EV experience. So the vision is to introduce this EVKit open platform to bring a lot of system layers such as ADAS, battery domain, body domain, all this is system level feature, push them to become an application layer. Once you push all this system feature become an application, you create this open marketplace for a lot of players to come in to redefine what the EV user experience is. Let's talk about a cloud native. Let's talk about digital twin. So what is a metaverse? Actually, it's a digital twin scenario. So from the technical view, when people talk about metaverse, from the technology and the ecosystem, you commonly will hear that 7 layer of the metaverse, from the experience layer, from the discovery layer, and then the content application creation economic layer, and spatial computing, of course, a 3D experience. And also this very important edge computing, this decentralization, microservices, all this using blockchain in the metaverse, right? NFT as such, and the human interface. And the last but not least is the infrastructure that can support the future of metaverse. So you compare this with the EVKit SDK design, it creates a very rich application ecosystem and open up a possibility of a marketplace for the automotive industry. And then from the creator economy, because you have opened up the system development toolkit SDK, EVKit, you can create a very vibrant development ecosystem. Last but not least, because you have this high computing power, 10 or 100 times of more than your iPhone or Android is a smartphone computing core, you can enjoy literally more 3D experience in your vehicle. And also introduce of this blockchain Web3. Mostly the first is to establish it such as a DID, decentralized ID, to play in this metaverse world. And not to mention this smart cabin, a lot of players has started coming in to redesign the smart cabin experience based out of this high computing power infrastructure. And assuming every future vehicle is a connected device, or the API that connected through the V2X, that complete really the mirror of the metaverse infrastructure. So basically, I can call that MIH is the gateway to metaverse for automotive industry. Thank you.